Okay, the next topic that I'd like to discuss is average rate of change. Average rate of change. Average rate of change is a very, very important topic, right? I'll say that to probably every topic, but this one is especially um, important topic. So I want you to pay close attention to this topic. So average rate of change. Oops. Rate of change. Okay, so let me give you a formal definition first, right? Definition. If A and B and A not equal to B are in the domain of a function y equal f of x, the average rate of change of f from A to B is defined as average rate of change. I really don't like this writing. Equal delta y delta x equal f of b minus f of a over b minus a. Okay, so let me box it up. Average rate of change. And like many definitions are, this definition, especially that part, it's kind of not that easy to understand. So let's try to read it together and let's try to understand what they're trying to say and how they set it up. So definition of rate of change is that if A and B are basically in the domain of a function and they shouldn't be equal. Well, first of all, why A and B cannot be equal to each other? Well, as you can see from here, right here, what will happen? A is equal to B. Then denominator becomes 0. And none of your math teacher, math professor would like to see denominator goes to 0 because that's almost like blasphemy, right? That's not allowed. Why is it not allowed? Because it's undefined. What do you mean it's undefined? Meaning they have no idea what that is, right? Mathematics is academic world that like to define every single things, and they have really hard time dealing with undefined. They really hate to see um, anything undefined, and denominator being 0 is undefined. And who would want that? No one. They'll do anything to avoid it, right? So B cannot be equal to A. So, and they are in the domain of function. I mean, the setup itself is a little bit funny, but what do they mean by this A and B are domain? What was domain? I mean, we mentioned it briefly in one of those previous video, but the main point concept that I want you to remember was domain is possible what? Domain is possible what value? X value. What's X? Input value, right? So in function, of course. So A and B is one of those input value. That's what they mean by in the domain of function, right? And they cannot be the same value. A and B is an input value, X value, and they cannot be the same of function f of x, basically. But why would they say f of x equal to y? Because they like to define this in the area of graph. Remember that, when we have a graph, we have this x line and the y line. So we say this is y-axis, this is x-axis, and sometimes you've probably seen that before. Instead of using y, some of us used f of x. So f of x and the y, they've been using this quite interchangeably, right? So don't worry too much about y equal f of x. Just understand y f of x as the same thing. So a and b are possible x value of this function f of x, and the average rate of change of this function f from average rate of change from a to b. A to b is defined as like this. Well, first of all, what is this small triangle? Again, that's delta, right? Delta, usually referring to difference or distance. So difference of y with respect to difference of x. Have you seen something like this before? Not exactly same, but something similar, same concept. What was it? Yep, spell it out. What was it? Yes, same thing as slope. Right? Remember that uh, the y change over x change, change in x, change in y over change in x, same thing. So what is a rate of average rate of change? It's basically a slope. It's the same thing. Difference in y over difference in x. Remember that a and b was x value. What about f of b and f of a? Look at this. If you replace this a and b, what do you get? The y. So these two are the y value, these two are the x value. You try to see the difference between the y value and the x value, not the difference in y, difference in x, and they put it into a ratio form, fraction form. That's average rate of change, right? Average rate of change. So, similar concept, almost the same concept, is what's called the secant line. So what is it? Same thing. Understand the secant line is using the same average rate of change. So let me give it the secant line. So let me give you a graph first. Let's say you have this. Okay. Let's say you have this function, and you would like to see the average rate of change from this point to this point. Let's say this point is A. Let's say this point is B. Well, if this is X and this is Y or f of X, what do you think this point be? That point right there. Well, that's A corresponding value, so this would be f of A value. Well, that's f of A. What do you think this point would be? This would be f of B, of course. So average rate of change from A to B would be the slope of a line passing through these 2 points. So if I just might have to try a few times to get the line that I like. Well, let's pretend that this, no, try it again. Oops. Okay, that's a little better. So this, the slope of the line passing through this point and this point, the slope is called the average rate of change. And what do you call the actual line? That T looks really horrible. That actual line is called the secant line, right? The actual line is what you call the secant line. All right, so let me give you an example. This is a very typical but very important example. Highly likely that you will see this example again in in one of your exam, right? Okay, let's see. Let f of x equal to 3x squared minus 2x plus 3. Right? The first part, find the average rate of change of f from -2 to 1. So we are saying this is A and this is B, right? That's what we're saying. Look at the setup. Look at the setup, right? From A to B defined like this, and that slope is average rate of change. So in this example, this -2 and 1 is going to be A and B. So we know that A is going to be -2, B is going to be 1. We also need to find f of A. So what's f of A? Well, replace this x by, well, I shouldn't say f of A. I should say f of 2, right? -2. Sorry about negative, because our B is -2. So if we replace this x by -2, then it will be 3, -2 to the square, -2 times -2 plus 3. Right. So what would that be? That would be, that's -2 to the square, that's 4. 3 times 4, that's 12. And -2 times -2, that's +4 plus 3, so that should be 19, right? That should be 19. What about B part? F of 1. Well, f of 1, remember f of x is this. I'm replacing this x by 1. So 3, 1 squared minus 2 times 1 plus 3. So that's 3 minus 2 plus 3. So that's 6 minus 4, 2, 4. Okay, so all we need to do is put that in to figure out the average rate of change. Average rate of change would be f of b, which is 1. So f of 1 minus f of minus 2 over 1 minus minus 2, right? Because our a is negative 2, right? So this would be 4 minus 19 over this double negative become positive 3. So this would be 4 minus 19, that's a negative 15 over 3, which is negative 5. All right. Okay, so average rate of change from negative 2 to 1 is going to be negative 5. Now the second part, part B, find an equation of the secant line containing negative 2, f of negative 2, and 1 and f of 1. All right, so this is basically negative 2 and f of 2 was what? 19, and 1, f of 1 was 4, right? We already found that in here, 19 and 4. So we just need to figure out the line equation passing through these 2 points. The m for this secant line that we already know from this average rate of change, which was negative 5, right? So I'm going to use this m, negative 5, and 1 point. I can choose this point, doesn't really matter. I'll probably choose this point because it looks easier. And remember that formula when we have a point and a slope? Y minus y1 equal m x minus x1. Remember that point slope formula? So I'm saying this is my x1, this is my y1. I'm going to use this point and this slope. So y minus y1, 4, equal m, negative 5, x minus x1, 1. All I need to do is just simplify a little bit. Y, negative 4, equal negative 5x plus 5, because I'm distributing this. Negative 5 minus 1 plus 5. Move this 1 to the other side. Y equal negative 5x. So if I move this, this becomes plus 4. And I already have plus 5, so it'll be plus 9. Just like that. And that would be my second line. Right? That would be my second line. All right. So please review this question a few times and make sure that you understand this question. Okay?